Section 5.4, ellipses. So we just looked at example 1 where we had an ellipse centered at 0, 0. They gave us the equation and we were able to identify the center, the vertices from the equation, and then we found C so that we could find the location of the foci and sketch the graph, of course. Okay, next, instead of sketching the graph, we're actually going to be writing the equation, but they're giving us a few details about the ellipse that we could put on a graph to help us see what's happening. So our vertices, it says, are at 0, plus or minus 8. Now this time, a point with a 0 at the beginning means we're not going to go left or right from 0, we're just going to go up. So 1, 2, 3, 4, 5, 6, 7, 8. Puts a point there, and then the other one would be 1, 2, 3, 4, 5, 6, 7, 8 with a point there. So there's our vertices. Since those are the vertices, the center would have to be at 0, 0 because it's going to be halfway between, right? So center at 0, 0. And then the foci, let's go ahead and sketch those in, would be at 0, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now the purpose of my graph is to just kind of see what's happening and give me a general feel for what I need in order to write my equation. So I know the center, I see it's not even asking me to find anything, it's just asking me to find the equation. So I'm going to have x squared over whatever a squared is, and I'm going to have y squared over whatever b squared is, and then that will equal 1. Well, we already know b squared because that's the vertical distance, and the vertical distance from the center to point B is a lovely 8, so 8 squared would be 64. We just don't know A. We also, though, happen to know C. C is 5, the distance from the center to the foci. So since we know what C is, we can actually use our formula. C equals the square root of a squared minus b squared, or b squared minus a squared. It's always the longest direction first, so in this case the vertices. So b squared minus a squared. And then let's just plug in the numbers we know. So we know C is 5, and we know B squared is 64. But we don't know A squared. So to solve this for A, we need to square both sides. So we're going to go 5 squared equals 64 minus A squared. So I just square both sides. Now, I want this A to be positive, so I'm going to move it over here, and then subtract my 5 squared over here, so it's 64 minus 25, which gives us 39. So a squared is 39, so that's the exact number that goes into our equation here, is 39. We don't actually need to know what a itself is, because it's not asking us to list the endpoints of the minor axis, and that's what that is. So all we're doing is writing the equation, so a squared, which is 39, is enough. Which is good, because the square root of 39 is like 6 point something. It's a little bit of a weird number. Alright, so standard equation for an ellipse with a center at hk is x minus h squared plus y minus k squared, just like our circle formula. But then instead of equals r squared, we have it over our a squared for the x direction, over our b squared for the y direction, and then equals 1. So this is the same formula we just talked about, only we were talking about the center being at 0, 0, and now we're moving that center to a different location, h and k. And a and b are always distance from the center of the ellipse, not from the origin of the graph. Alright, I'm going to actually clear off this next problem so that we have some who can follow along with what's happening here. I'll talk through it as is, and then I'll start it over in the next video. So if you want to just go to the next video where I actually delete it and start over, that would be fine. So from our equation, we have x plus 1, so we have minus 1 for our center. We have y minus 2, so we have positive 2 for our center. And then we have 9, so that means a squared is 9. So a would have to be 3, the square root of 9. And then b squared is 25, so square root of 25 is b, which is 5. Since this number is bigger, that is on our major axis. So the major axis is going to be vertical here at the line x equals -1. And the vertices will be located 5 above our center at -1, 2, so up here at -1, 7, and down here below our center at -1, 2, so at -1, -3. So really you can just take that second number and add 5 and subtract 5, and the -1 stays the same because those -1s are on our major axis at -1. Alright, next let's talk about the minor axis. So the minor axis would be this direction, horizontally from one side of the ellipse to the other, so that is going to happen at the line y = 2. The endpoints of the minor axis will be a distance of 3 from the center. So we'll have one here, 3 from the center, and one here, 3 from the center. So that's affecting the x value this time instead of the y value. So that y value is staying at 2, just like our equation is y = 2. But the x value, the center is at -1. We're adding 3 to -1 and we get 2. We're subtracting 3 from -1 and we get -4. Or you can just count it and find those numbers that way. So there's our minor axis and the endpoints of our minor axis. Alright, last thing we need to do is find our foci. So to do that we need C. To find C we use our a squared and our b squared, and the bigger number goes first. So b squared in our equation is 25, and a squared in our equation is 9. So we just take those two numbers in our equation, bigger one minus smaller one, get that value, square root it, and that gives us the length to the focus. In this case, it's a nice pretty 4. Square root of 16 is 4. So the foci are going to be 4 from the center upward and 4 from the center downward, which means we're adding 4 to the y value. So we have -1, 2 plus 4 is 6. -1, 2 minus 4 is -2. There's our foci. Here's our graph. We've finished this problem.